Hello. I think at the end of our class today, there were still questions hanging out there on how to make the graphs and what to do with the data. Let's start first with the mealworm experiment, the animal behavior investigation. What you see on the screen is the mealworm data in Microsoft Excel 2007. I will be reading from the instructions which I emailed to you. This is the writing your report instructions under results. If you don't have this document, the sub has some copies and you can get one. You can pause this video at any time. You can rewind. It's beautiful. How to make a graph in Excel 2007. Select the two columns of data in the spreadsheet that you want to graph. Include the labels. Click Insert tab. Choose Line and the upper left example that appears. The chart appears and you are automatically in the Design tab. Click on Select Data. Choose Edit under the horizontal category axis. Click on the button immediately to the right of the Axis Label Range entry box. In your original spreadsheet, click and drag to select all the times 0 through 10 minutes. Click again on the button immediately to the right of the Axis Label Range entry box. Click OK and click OK. Voila! You have a chart. Click on Move Chart Location in the upper right part of the computer screen. Select New Sheet and OK. Click on the Layout tab. Choose Axes, Horizontal, and more options. Toward the bottom of this dialog box, choose Position Axis on tick marks and close. Still in the Layout tab, use Chart Title and Axis Titles to perform those functions. Once these boxes are there, you can simply click in the box and type whatever title you want. That is how you make these sorts of graphs in Excel 2007. Next, we're going to look at the primary productivity data. Been doing some thinking, did some talking with Rachel, made a few changes here. When we talk about change in dissolved oxygen, that should be the final minus the initial. What changed over time? From that perspective, and with that definition, the dark bottles do indeed have negative changes in DO. They started at one amount and they ended at a lower amount due to aerobic respiration. The amount of dissolved oxygen has decreased. It is a negative change in DO. However, for all these boxes, we want a formula that tells the computer, in this box, I want you to put the number that is equal to the DO final, found in B5, minus the DO initial, found in B4. The B4 is the address of the cell. It's in column B and row 4. In cell B6, I'm asking the computer to take the number in B5 and subtract the number in B4. And that gives me this answer. Once I have a formula set up the way I want, I can move the cursor till I get the thin black cross with no arrows in the lower right corner, and I can click and drag that across. It copies the formula in the same orientation. Here it was B5 minus B4, C5 minus C4, D5 minus D4. You get the idea. The numbers change. It's doing the same orientation. Hey, take that number directly above this cell and subtract the number 2 cells above. And it takes that orientation no matter which cell you click on. Now back to our more conceptual discussion. Average respiration is not a negative amount. Respiration uses oxygen. How much oxygen has been used? If it's been used, there had to be something that was used. And a something is positive. So to get this average respiration, I am indeed going to use the change in DO from my dark bottles. I'm going to average those numbers. To do that, I click on this cell, and I told the computer, let me redo this for you. I'm going to tell the computer to sum those 5 cells. S-U-M. Sum is addition. Which 5 cells? Parentheses. The first cell that I want to sum is G6. G6. Enter a colon. The last cell I want to sum is K6. K6. Close parentheses. I want to sum those and divide by 5. Now I have the average change in DO. But as I just discussed, this should not be negative here. Why not? Because respiration doesn't use a negative amount of oxygen. It uses a positive amount of oxygen. So I'm going to return to this formula and simply tell the computer, take the opposite of that. What am I entering? I'm entering a dash found on the key immediately to the right of the 0 in the number keys at the top of your keypad. Enter. That is now positive. Average net productivity. This refers to the light bottles where photosynthesis outweighed respiration. Respiration is still happening in these bottles at an average rate of 0.4 milligrams of oxygen per liter. But photosynthesis is happening at an even greater rate, resulting in a net production. To get that number, I sum the 5 change in dissolved oxygen concentrations from the light bottles, cells B6 to F6, sum B6 to F6, and divide by 5. That's my net productivity. Is that how much oxygen they produced? No, they actually produced more because they produced enough oxygen to get used in respiration. That oxygen doesn't show up when we monitor the water. Why? It's been used up in respiration. So to get a more accurate picture of how much oxygen was produced, I'm going to add the amount that was used in respiration on average and the amount that was net on average, and I'm going to get a gross productivity. Once again, this particular experiment was designed to do one thing: get an idea of what the primary productivity is for our stretch of the river, our reach, which we are studying. The second part of the experiment that most of the class did had a different purpose, and that was to simulate how is primary productivity affected as you move deeper down in a still body of water. Light diffuses, light is blocked, there's less light getting to the producers. What does that do to productivity? Well, as we talked about in class, let's talk first how to calculate this one more time. You have 4 bottles in each condition, and you want to average the temperatures, the DOs. To do that, you select the cell that's underneath the average labeled column. It's under the label for an average in that column. Go up here to the sum key, but don't click on the sigma. click on the arrow so you can choose the option average. It puts a little dashed line around the 4 cells that it's going to average. Is that what I want averaged? Yes. Hit enter. Once again, I can copy that formula by getting the solid black cross in the lower right corner, clicking and dragging down. Because I want the average final temperature, I want the average initial DO, and I want the average final DO, and the average change in DO. I want to do the light average. I click on the box under light average. I go to the sum key. I click on the arrow. I choose average. Whoa! It went all the way over here to average. That's not what I want. I don't want it to start in B14, B14. I want it to start right here. This is G14. And it's not 14 because of the temperature, it's 14 because of this row number. So I'm going to come over here and insert my cursor, get rid of the B, and change it to a G. Are those the 4 cells I want averaged? Yes. Hit enter. Notice, when you use the average function, you don't have to tell the computer to sum them all up and divide them. The function average will do that. Once again, lower right corner, click and drag down, you've got your averages. You're going to do that for dark, light, 1 screen, 3 screens, and on down the row. Alright, what to do with our data? You need to understand the graph that was in the packet I sent. If you couldn't get the pictures, you need to get a hard copy of that. The sub has one, you can make a photocopy. Someone else in the class may have one. What is our issue? All our changes in DO are negative due to the large gain in temperature, 14 to 23, 14 to 25. Warm water cannot hold as much DO as cold water. So that is skewing our results. But we can still use our results. This change in DO is still an indication of, I need to change this, net productivity. Net is the difference between the end and the beginning, and we can still calculate that. This will still give us an indication as to the effect of decreasing light as you move deeper in water, or for any reason. As light decreases, what happens to primary productivity? Think about it. What are other conditions that happen where light decreases? This chart down here is simply where I've entered the change in DO for the bottles. The light bottle had an average change of negative 2.8 milligrams per liter. The 1 screen bottle had an average of negative 3.4 milligrams per liter change in DO. I'm simply adding those numbers in there. Negative 3.4, that should be. You would have caught that even if I hadn't. Running out of time. I'm going to choose this. I'm going to go to Insert. I'm going to go to Line. Upper left. Ta-da! Yikes! The axis is up there. I want to go to Layout. I'm going to choose my vertical axis, more options, and I'm going to tell it to cross at -7 or -7. Voila! Now my axis is down here at the bottom. Axis, horizontal, more options, position on tick marks, close. That should do it. At this point, you should be able to use the things from the first part of the video with mealworms to add your titles.